Rational expressions. Rational expressions are just another fancy way for saying fraction. So basic fractions are ones that do not have variables attached to them. All right, I mean, a lot of you are going to be just fine with a majority of these. So anytime you have fractions, your goal is to always make sure that you have a common denominator first. And most of the ones we're going to do mostly with common denominators and then some with unlike, so you have a little bit of both. But for the most part, you know, the denominator stays the same. Add or subtract the numerators, simplify when you're done. All right? If there's nothing to simplify, then you're done. We don't want mixed numbers because mixed numbers are not useful for the most part. And so if you get something where the numerator is greater than the denominator, just simplify it and leave it an improper fraction. All right? So, I mean, you guys know how to do those type. For the most part, we're going to start introducing variables. So same thing, as long as they have the same factors in the denominator, they're already fractions with common denominators. We can add and subtract the numerators. Right? Thing is that you have to make sure that you combine like terms correctly and write them in descending order. So like 8x and 5 have nothing in common. So all you can really do is take these two fractions and write them as a single fraction instead of, like, you can't combine the 8 and the 5. Right? The other thing I want to get in the habit of is we don't have necessarily like a condition like we did before where we're not canceling something out right now, but I still want you to start writing the values now of what the denominator is not allowed to be. So like when we were doing conditions, we wrote on the condition of the factor that we canceled, but we didn't really look at the ones that are still left because there's other conditions that we have to focus on. And so like right now, I want you to be able to write things like when the variable in the denominator is equal to 0, this fraction right here would be undefined and something would happen. So even though we didn't cancel a y, we need to start writing this extra condition so that way we can attach values that you could not use for substitution no matter what. The x doesn't matter. So we're only focusing on when is the variable in the denominator equal to 0. All right, so that's the only thing that we're going to focus on as like an extra piece today, is if you have variables, values that you could not use in your substitution later. Right? And it's only about the denominator. All right, I mean, we can combine, we can write as many fractions as we want. So like 15 over x minus 12 over x plus 4 over x. So you've got this like string of fractions, right? If you've got adding or subtracting that separate them, but all the denominators are already the same, you're not going to write this as x cubed because you're not multiplying. You're just saying they all have the same denominator, so that's my denominator. Add and subtract the numerators, however I got to do it. So, I don't know, what is that, 7? Yeah. So 7 over x. So that would be the simplified, like taking 3 separate fractions and rewriting it as one fraction, but we still could not have x equal to 0 to continue to keep a like correct fraction. Like I'm not allowed to have, I can use anything I want for x as long as it's not 0. So I could use a fraction and put that in there and do some algebraic work. I just couldn't use 0. That's the only one. And so we're starting to build like what we call our domain. So right now, everything is possible. All x or all like y values here are possible except for 0. Like all x values are possible, just not 0. So you can use any number you can create in your head, you just can't use 0 for substitution purposes. Ones that usually start to throw people off are when we have bigger expressions. So like we have 3x plus 10 over 8x, and I want to subtract off x plus 4. So they already have the same denominator. That's not a problem. The problem is that when you're saying that you're trying to subtract off this fraction, all of this in the numerator has to get the subtraction. So you have to actually distribute that subtraction sign to all of the terms in the numerator, not just the first one you see. And that's usually the biggest mistake. And so really what you're looking at is you're looking at a denominator of 8x, but you're looking at having the 3x plus 10 and subtracting off both of the other terms. So I'm going to write those in red so you can see that the negative has to be distributed to everything. And then you can combine all of your like terms. All right? So that's the biggest key right here. When you see subtract, if there's multiple terms in the top, everything has to get it. Right? I don't know what that is. 2x plus 6. So now you're down to this point, and you have to now factor. All right? So the other ones we didn't have to do anything to because it was like a simplified fraction or it didn't have like terms. But now when you look at this, the 2 and the 6, they have something in common up top. And so I can factor and simplify this fraction down a little bit. All right, so I'm going to factor out the 2 from the numerator. And now what I have is I have some monomial factors like the 2 and the 8 and the x. And then I have a binomial factor of x plus 3. All I can do is simplify this 2 and this 8 by taking out a factor of 2. And so I can make my fraction a little bit smaller and a little bit more simplified by factoring out that GCF. And so your final answer is not actually done until you do that. And so this would be your simplified fraction, that x plus 3 over 4x also cannot have x to be 0 in the denominator. So once you do your adding or subtracting, you always have to look to see, especially when you have 2 terms or 3, if you can factor that somehow. And then once you factor, is there a way to simplify that even further? And that's going to come up a lot, and we're going to do that a lot more tomorrow, but it's going to come up a little bit today. All right, so those are really just ones where you already have like common denominators. And then you have some where you have like unlike denominators. All right, like x over 8 plus 3 over 4. And you have to remember, like, to get common denominators, you can't add something to the denominator. You have to have factors. So it has to be something that you can multiply both top and bottom of the fraction to make it look the same. So like on this one, just going to multiply top and bottom by 2, so that way I can make a full 8 in the denominator. And so I have x plus 6 over 8. And you can't do anything. Like one of the other videos we watched with that Nancy Pi was like, you can't simplify 6 and 8 because even though we're not writing it this way, there's invisible parentheses connecting those two terms together. So unless you can factor something out of these two and cancel it on the outside like we did over here, you can't do anything. You have to leave it alone. And so this would be your final answer, your simplified fraction. And there's no extra condition on there because there's no variable in the denominator. So I don't have to ever worry about, is the denominator going to be 0? No matter what I put up there for x, everything is fair game. Right? This will always be an 8. So we've just got a couple of them. So you have 3a plus 2 over 10a. And again, don't simplify that or try to do anything weird with that. All right, and then I want to add the fraction 7a over 5. So you always want to look at the larger denominator and see if like the number portion is already a multiple of the other. And so if you want to off to the side, you can try to figure out like what your common denominator would look like. But for this fraction, I'm missing a 2, so that way I can make the 10, but I'm also missing an a. All right, so top and bottom of this has to be multiplied by both the number I'm missing and the variable that I'm missing. And so when I simplify down my multiplication in the bottom, I just have 10a because that was my common denominator. But when I look at what's happening in the numerator here, I have a 3a, a 2, and then I have a 14a squared. And that's not written in descending order, but it's also a quadratic. So somehow, like, I usually would like to look at that and say, is there a way to factor that? Right now, I don't care, right? And the only reason why I don't care is there's no point in me looking at how to factor this when I couldn't possibly cancel anything out from the denominator. So when you have a quadratic, the only time you're going to look at trying to factor the quadratic is if each term has something in common, like a common letter, or sorry, a common number. Like if they all had a 2 or a 5 in common, then I'd try to factor something out like here. All right. Or if they all had an extra a, like if this was an a cubed, like a 2a and an a squared. If they all had an extra a, I'd want to try to cancel it out with the one in the bottom. All right. But otherwise, all of your other quadratics are like binomials times binomials. And if I can't factor, like there's no point in me trying to factor that when I can't cancel it. All right. So the only thing that I don't like about this one is that I didn't write it in descending order. All right. But I also need to write my little condition. So I'm going to rewrite it because I like descending order. But all of this, again, like a cannot be equal to 0. So don't change the variable. All right, don't just get in the habit of writing x can't be 0. It's whatever the variable is in the denominator can't be 0. And so you can leave that alone, all right, because I don't want you trying to factor this. I don't even know if it could be factored. It might be factorable, but I don't really care. So if you get a puzzle or a worksheet where you have to try to find your answers, and one of them like has it in factored form, you are going to have to factor just so you can find your answer. But otherwise, leave it alone. Like you don't have to do anything extra with it. Yeah.
So if you don't factor the quadratic, it doesn't like simplify both denominators, what you're saying.
Yeah, like if there's no way to cancel out, like if there's no binomial, because usually when we have quadratics, we have binomials. If there's no, unless there was like a binomial in the denominator like this, there'd be no reason for me to try to sit there and factor the numerator to cancel something. So if I can't make that work, then there's no point in me wasting my time. Like I said, unless you've got one of those puzzles I give you where you have to find your answer, don't worry about trying to factor it. I know you're looking for like factors of 28 that add up to be 3, and they're all positives. That doesn't factor anyway. So you can't factor that one no matter what. All right, so like 3 over 4y squared minus 5x over y. Like, what are you missing in the right-hand fraction? What do you need? You just need a 4y. All right, I'm going to rewrite this. Let's see. I'm going to leave my 4y squared in the bottom. But when I rewrite this, I'm going to put the ones with the variables out front. And I can't do anything with that. That 3, the fact that it's a plus 3, and that's nothing in common with a 20 or a 4, means I can't do anything. I'd have to just stop. And I only have one variable in the denominator, and so that's the only thing I have to worry about considering when is that going to be 0. So there's going to be a lot of times when you're not able to actually simplify or cancel them. If you look at all these ones we're doing, like there's only one where we were allowed to like factor and cancel. Everything else is pretty much, you know, figure out what you're missing on that fraction by factor-wise and then just write it in descending order. There's not a huge amount to do. So any questions on this, things that you want to know, that you want clarification on? Again, like when we're writing like the y or x cannot be 0, those are not on the condition of. That's not the same thing as before because we didn't cancel anything, but it is part of the not allowed domain stuff that we will start talking about.